Alright, good afternoon class, and happy Wednesday. Welcome to science. So today we are going to go over our lesson on, continuing the chemistry unit, we are going to go over our ionic and covalent bonding today. So, right off the bat, our learning goals are going to be, we're just going to review ions and their ionic charges, cations, anions, metals, non-metals. We're going to give a quick recap of that in case anybody's forgotten. And so, following that, we're going to get straight into our bond types. We'll touch on ionic bonds and covalent bonds. We won't really get into anything heavier than that today. And then we'll wrap it up with just some understanding properties. So, quickly, let's go over what our ion charges are. So, let me just draw a quick little periodic table for you here. You all have this periodic table in your packages that I've handed out to you. I believe it's on the last page there. It's just flip to that if you've got a chance. I'll just draw a quick little one out here for us, just for purposes. Let's see. Here we go. Okay, here's our periodic table. Remember our little staircase there. So, on the left side of the periodic table, what type of elements do we have? Metals or non-metals?
Metals.
Metals, exactly. Right here. So on the left side, or on the right side, we have, conversely,
Non-metals.
non-metals. Now let's remember our octet rule. Elements in the periodic table, in order to become stable, they want to have a full valence shell. And by full valence shell, I mean they want to have 8 electrons, in their outer shell, in their outer orbit. So if we have a metal in group 2, let's say, group 2, how many electrons are in this metal's valence shell? In group 2?
2.
2 of them, exactly. Now remember, we want to become stable here. We want a full valence shell. So what are the metals going to do in order to become stable? Specifically in group 2, are they going to try and gain 6 electrons to get a full 8? Or are they just going to lose 2?
Lose 2.
They're going to lose 2. Why do you think that?
Because it's easier than gaining.
Exactly, because it's way easier for them to just lose 2 versus gaining 6. So if we lose 2 electrons out here, what does that do? We've lost 2 negatively charged particles. What is that going to leave us with? What type of charge? We've lost 2 negatives.
A positive.
Positive charge, exactly. So our metals will form positive charges. And what type of ion is this? Positive? It's a cation. Perfect. Metals will form a positively charged cations. Non-metals, on the other hand, if we have something in group 7, how many valence electrons? 7 valence electrons. We want to get to 8. Remember that octet rule. 8 electrons to make a full valence shell. What do we want to do here? Will we lose 7, or will we just gain 1?
Gain 1.
Why?
Because it's easier.
Because it's easier. So if we gain 1 negatively charged particle, what is the charge here for our non-metals? It's going to become
negative.
It's going to become negative. So our negative forms what type of ion? Not a cation. It forms
an antion.
Close. It's an anion. Anion. Very good. Very good. They're anions over here. So we've got 2 main types. This kind of area right here we won't really worry about right now. Those are the transition metals. They have a lot of different charges. We won't really worry about that right now. This is what we've done up to this point. What we're going to do, so quickly give me an example. Just look on your periodic table here. What is an example of a metal?
Magnesium.
Magnesium. What else?
Lithium.
Lithium. One more?
Iron.
Iron is a metal, but remember, iron is found in this section, so we won't.
Potassium.
Potassium. There we go. There's another one. Okay, and non-metals?
Sulfur.
Sulfur. Okay.
Oxygen.
Oxygen. And
Chlorine.
chlorine. Perfect. Okay, so we have our metals and our non-metals. Now we're going to get into what we call bonding. So if you flip into your package there, the first line in that package handout you have right here, it says bonding is the process of two or more atoms joining together to form a compound. Two or more atoms joining together to form a compound. If we're talking about ionic bonding, our ionic bonding is the joining of a metal and a non-metal. Just write that out here, ionic bonding is the joining of two or more metals and non-metals. Okay, metals and non-metals. Ionic bonding, metal, non-metal. What is interesting about the fact that we have positive cations for our metals and our negative anions from our non-metals? What sticks out about that to us? If we've got a positive and a negative charge.
They attract each other?
Exactly, they're going to attract each other. So if we have, let me just write that here in red so we don't remember, so we don't forget, sorry. Metal and a non-metal is the positive cation mixing with a negative anion. So looking in your packages there, the first example you have is sodium and chlorine to produce sodium chloride. Let's draw this out here. We'll work through it together. We have sodium and chlorine to produce sodium chloride. Let's draw this out. Okay. Sodium and chlorine to produce sodium chloride. Sodium, what group is sodium in?
2.
It's in group 2. So how many valence electrons does it have?
2.
Oh,
Sodium.
sodium
One.
is in group 1. Sodium is in group 1. So it has 1 valence electron. What about chlorine? Chlorine is in group
7.
7. So it has how many valence electrons?
7.
7. 1, 2, 3, 4, 5, 6, 7. Now the interesting thing about ionic bonding is because we have the joining of two or more metals and non-metals, what's going to happen is a complete transfer of electrons. A complete transfer. They're not sharing at all. Sodium we talked about, because it's a cation, it wants to lose its electrons. So we've got to get rid of this thing. And it just so happens that our non-metal, chlorine, which is an anion, wants to gain that electron. So what's going to happen here? Sodium is going to give its electron to chlorine. Just like that. And so now we have 8 electrons in chlorine's outer valence shell. And sodium has lost its 1 electron. So everybody's happy. We've got 8, and we don't have any random electrons hanging out in sodium's valence shell. So what this is going to look like here, sodium chloride. Sodium chloride. These have mixed together, these have bonded in an ionic bond. Next one you have in your package there is aluminum and oxygen to create aluminum oxide. So what I'm going to do is I'm going to give you guys a couple minutes, just work through that, grab a partner if you need to. Ionic bonding, remember aluminum is our metal and oxygen is our non-metal. Joining two or more metals or non-metals. It's going to be a complete giving of electrons, okay? So let's just work through that for the next couple minutes. I'll give you some time, and if there's any questions, feel free to ask. We'll take it up together, compare my answers to yours, and we will see how you guys are doing with ionic bonding. So, aluminum and oxygen to produce aluminum oxide. Did you guys have a minute to get through that? Is everybody okay so far? Okay, so has everybody had a chance to give aluminum and oxygen to create aluminum oxide a chance yet? That's example number 3 in your package there. You've got a blank space to work on that. Has everybody gotten this far?
Yeah.
Okay. So let's work through it. Aluminum has how many again? Sorry?
3.
3 in the outer shell, and oxygen has 6. Okay. So we're going to have some electron sharing. Remember, ionic bond is going to be a transfer of electrons, complete transfer. So let's transfer 1, 2. This oxygen now has 8, it's happy, but we've got a problem. Aluminum still has 1 in its outer shell. So let's add another oxygen. 1, 2, 3, 4, 5, 6. Let's transfer this last aluminum. Aluminum is happy. Oxygen is not. We still need 1 more. So let's add another aluminum. 1, 2, 3. We can now transfer this over here. This oxygen is now satisfied. But this aluminum still has two electrons that need to go somewhere. So let's add another oxygen. 1, 2, 3, 4, 5, 6. Bingo! We've got a match. Aluminum has 2 extra electrons. Oxygen needs these 2 electrons. 1, 2. Let's check our work here. 1, 2, 3, 4, 5, 6, 7, 8. This is happy. 1, 2, 3, 4, 5, 6, 7, 8. This is happy. 1, 2, 3, 4, 5, 6, 7, 8. Bingo. No more electrons hanging out with aluminum. Everything is worked out. What this leaves us with now, count them up, 2 aluminums, Al2, 3 oxygens, O3. This is an ionic bond between aluminum and oxygen to form aluminum oxide. Any questions with that? Any outstanding, burning? Say it now. Anything?
No.
No? Okay. We'll move along then. So there's ionic bonding. Next one is, if we just bonded a metal and a non-metal, what do you think comes next? It's a covalent bond, and what is a covalent bond going to bond together? To what types of ions? Covalent bonding.
Non-metals.
Exactly. So a covalent bond. Flip to the back of that page there. We've got a couple examples here. So it says, covalent bond is a compound composed of 2 or more nonmetals. A compound composed of 2 or more nonmetals. Let me underline this. Let me stress this. This is important. 2 or more nonmetals. 2 or more nonmetals. Okay. So give me an example of nonmetal.
Sulfur.
Sulfur. Yeah. Okay. Another one.
Oxygen.
Oxygen. Yeah.
Nitrogen.
Nitrogen. Yeah. Nitrogen.
Fluorine.
Fluorine. Yeah. Okay. So let's look at, in our ionic bonds, we had the complete transfer of an electron. In a covalent bond, what's different is we don't have complete transfer. We have sharing of electrons. I'll do this in red because it's important. Sharing of electrons. Sharing of electrons in our covalent bonds. So the first example you have in your package here that I've handed out is chlorine gas, Cl2. Cl2, chlorine gas. How many valence electrons in chlorine? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now notice, because we're not going to have the complete transfer of an electron, what we're going to have instead is these 2 chlorine particles will share one of their electrons with each other in order to complete their octet. Okay, so watch right here. Chlorine has 7 valence electrons. We've got 2 chlorines. What we're going to do, rather than a complete transfer of electrons, is we're just going to share one between them. We're going to create a bond, a covalent bond between these chlorines. What this means now is that this set of electrons, there's two in a bond, will both 100% be involved in this chlorine as well as this chlorine, completing both of their electron shells. Let me draw this out for you because it's kind of a difficult concept to understand. I'm going to do the exact same thing, but instead I'm going to use fluorine just because it's a little easier. So we have one fluorine here, one fluorine here. That marker's dead. One fluorine here, one fluorine there. This is going to be fluorine gas. F2. 1, 2 in the first shell for each. 1, 2 in the first shell for the second one. How many valence electrons in fluorine? It's group 7.
7.
7 valence electrons. 1, 2, 3, 4, 5, 6, 7. The next fluorine. 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Notice the overlap here. Okay, so both of these electron pairs are now going to rotate in this fluorine's valence shell and this fluorine's valence shell, therefore completing the needs for the octet rule here and here. Both of these are happy. What we're going to draw this as, fluorine is going to be bound with one covalent bond. There's one single covalent bond for fluorine gas, F2. Remember, this bond counts as 2 electrons. So we've got 2, 4, 6, 8, 2, 4, 6, 8. They're happy. That is a single covalent bond. Remember, in your packages, you have written down 3 examples of you to work through. Take some time to go through that right now. There's nitrogen gas and there's carbon dioxide. All of those are nonmetals, and nonmetals binding, they will form covalent bonds. So take a couple minutes, work through that, then we'll take it up. If there's any questions, I'll be walking around to help you out. Alright, how is everybody doing? Good with that? So just to wrap up, covalent bond, 2 nonmetals, sharing of electrons, ionic bond, complete transfer of electrons, we'll work on more tomorrow.